Hello, everyone. Welcome to our program on solar eclipses and the June 10th Sunrise Scimitar, presented by noted meteorologist and astronomer Joe Rayo. The program is sponsored by the Lewisboro, Pound Ridge, and North Salem libraries, so thank you to our sister libraries. Many of you may know Joe as the chief meteorologist for News 12 Westchester and Hudson Valley for over 21 years, before moving on to Verizon Fios One News. He also, since 1986, has served as an associate astronomer and lecturer at New York's famous Rose Center for Earth and Space, which houses the Hayden Planetarium. In addition, he has written a few children's books on weather and stargazing, which are available through the Westchester Library System. Welcome, Joe.
Well, thank you very much, Liz, and thank you very much all for attending the talk tonight. I'm actually, quite frankly, I'm excited because, and I get excited whenever I know that there's a very special event going on or will be going on up in the sky, and there will be 2 weeks from today. And I've got my fingers crossed, and I'm trying to do whatever I can to try to get the weather gods up there to cooperate so that we'll be able to see this 2 weeks from today on Thursday, June the 10th. And we'll be talking about that in this talk. We'll also be talking about not just the eclipse in 2 weeks, but also eclipses in general, solar eclipses, lunar eclipses, eclipses of the moon, and how they happen. Have you ever wondered when you heard about an upcoming eclipse, you say to yourself, well, how do they know? How do we know that there's going to be an eclipse of the moon or eclipse of the sun? We're going to talk about that as well. So what I'm going to do is I'm going to share my screen right now. And this is so wonderful. I was telling Liz before the show that you're talking to somebody who until recently was still giving talks using a slide projector, using an old ectographic. So this whole thing with PowerPoint is intriguing to me, but also quite interesting and very convenient. Certainly you can't do any slide projecting over the internet, but you can do it here on PowerPoint. Okay, so we're going to start off the talk talking about an object that has been in our sky of late the last few nights. Hopefully you had a chance to see it, the moon, which has been full. The best thing about the moon is, of course, it provides us with light. It provides us at night with being able to see during the overnight hours, especially around the time of full phase. And the ancients, hundreds and thousands of years ago, looked upon the moon as not a big ball of cosmic pumice, if you will, circling the earth, but as a goddess. And that goddess's name was Selene. And Selene was in control of the moon. But the most important object in the nighttime sky was the object that we see during the daytime, and that is the sun. What a wonderful object. It's a tremendously hot ball of gas, as we all know. 864,000 miles across is the part we see normally. All gas from its surface to its center. Gas clear into its entirely hot central region. 11,000 degrees on the surface. Almost 30 million degrees at its center. Gas, nonetheless, all the way through. Gas so dense that the average weight of a small amount of this, a cubic centimeter of this, is heavier than the weight of an equal amount of water. We know the sun to be a star, the nearest star relative to us, the center of our solar system. But again, hundreds and thousands of years ago, we equated the sun to be a god. That god's name was Apollo. Every morning, Apollo would appear above the eastern horizon, and he rode a chariot, if you will, across the sky, carrying the light of the sun with him, high into the sky at midday, and then gradually the chariot would work its way down toward the west, disappearing beyond the western horizon in the evening, leaving us in darkness, and reappearing again the following morning. So that's what we thought of the sun and of the moon. And woe if anything were to happen to the moon and the sun in the sky. These were our two most prominent and most important sky objects. And we knew, even thousands of years ago, that if it were not for the sun, all life on this planet would not exist. We depend upon the sun, its light and its heat. And we have stories that go back all the way into the Far East about events that put the sun and the moon in jeopardy. One of the most famous occurred 41 centuries ago, as dictated in the Chinese chronicles. The day was bright. The great sun hung motionless in the sky above the Yangtze Valley. The Chinese storyteller records what happened next. The dragon, Lung, restless with hunger, appeared, and before the eyes of the frightened people, Lung began to devour the sun. The day grew darker. The people raised a din, a chant, a prayer. The dragon was startled. The sun slipped from his jaws, and Lung vanished to await another chance. Our computers tell us the date. It was October 22nd in the year 2137 BC. Again, 41 centuries ago. And the two court astronomers who were supposed to warn the people in China of this event, or that the event was actually occurring, Hai on the left and Ho on the right. Well, unfortunately, the night before the eclipse, they kind of had a little bit too much to drink. In fact, they over imbibed, and by the time the eclipse actually occurred, they were just flat out inebriated. And so they did not serve their task of warning the emperor and warning the people that the eclipse was occurring, that the dragon was eating the sun. And in the aftermath, Hai and Ho paid the ultimate price. The price being that they were decapitated. That was the price that they had to pay for not living up to their duties as court astronomers. And again, the spectacle of an eclipse of the sun or the moon, especially the sun, was one of it frightened the people to see that suddenly the luminary of the day or the luminary of the night was suddenly and completely sometimes disappearing. What monster, what dragon? Some cultures thought it was a pig or a goat or something up there that was consuming the sun or the moon. In any case, eclipses were important in the minds of the people to know when they were going to occur. Now, they didn't occur every month. In fact, the eclipse, when it does occur, is something that happens once in a great while. And it's not a haphazard schedule. There is a definitive, a very definite schedule as to when and how they occur. You see, the moon's orbit is tilted by only about 5 degrees relative to the orbital plane of the Earth. What that means, however, is that when we have a full moon, more often than not, the full moon will pass either above or below the shadow of the Earth. And during an eclipse of the sun, well, the new moon will seem to pass either to the north of the sun, above it, or sometimes pass below the sun to the south of it. It's only on unusual occasions, it seemed, that the path of the moon would take it either directly across the sun's face or partially across the sun's face, resulting in an eclipse. There is an old limerick that speaks of this. It says, "Sometimes I think of the sun and the moon as lovers, lovers who rarely meet, always chase, and almost always miss one another. But once in a while they do catch up, and they kiss, and the world stares in awe of their eclipse." Of course, the time when the moon and the sun are together, especially during a total eclipse, doesn't last very long, only a few minutes at most. But when it does happen, well, there you see Selene getting together with Apollo for a few precious minutes. And meanwhile, down on the Earth, we have our special instruments, our binoculars, our telescopes, watching and gazing upward as these two have a celestial tryst, so to speak, in the sky. Well, the fact remains that watching these events, watching these eclipses over hundreds and thousands of years, eventually man began to learn. In making these observations, recording these observations, here you see a Babylonian tablet which records the occurrence of an eclipse of the sun around 1000 BC. You get enough of these records together, and you get learned men who were able to read the records, and soon a pattern began to emerge. And soon that pattern allowed for prediction. You know, the Hai and Ho, they couldn't predict the eclipse. Their job was to watch the sky, and when they saw the first sign of an eclipse, that's when they had to tell the people that this was happening. But to know when an eclipse was going to occur in advance, 41 centuries ago, that was pretty impossible. But over the span of time, as we gained more and more observations, we were able to begin to notice patterns which allowed for prediction. For example, I'm sure you've all seen this at one time or another in your lives, maybe not in person, but in books and maybe on television. This is Stonehenge, and Stonehenge was built in Salisbury, England, about 1500 BC. We believe this is what Stonehenge looked like when it was first built. And it was used for what? To observe sunrises and sunsets. We know, for example, also that it was used for plotting the time of the seasons. There's a keel stone that's in the middle of Stonehenge where the sun rises directly over that particular stone on the first day of summer, the summer solstice. But notice also around the periphery, around the edge of Stonehenge, there are holes. They're called Aubrey holes, and they were used for rocks that were placed in these holes as markers, markers to mark off the places of the sun and the moon in the sky. Here you see the circle of Aubrey holes. The sun marker was moved 2 holes every 13 days. The moon marker moved 2 holes every day. And then you have the markers that defined when the moon would cross the Earth's orbital plane, which we call the ascending node. We have markers for that. Or when it crossed the Earth's plane going southward in a descending node, the marker was moved 3 holes every year. These helped in predicting the times of future eclipses, because if we knew when the moon crossed that plane of the Earth's orbit, that would set the stage for possibly an eclipse of the sun or moon to occur. You take a look here. You can see that the men who were able to define the movements of the planets, the sun, the moon, the Mercury, Venus, Mars, Jupiter, Saturn, these go probably the very first astrologers, if you will. These were the guys who defined the pseudoscience of astrology. And perhaps if you look in your newspaper and you read your horoscope today, I still kind of scratch my head and wonder how people in the 21st century believe that a specific part of the sky where a planet might be might have a significant influence on their lives. But that idea, that concept goes all the way back to before the birth of Christ. But these people wielded power because eventually these people were able to at least make a prediction a few days or maybe a few weeks or even maybe a few years in advance about where the planets were going and also where the moon and the sun were going to be and whether or not we were going to have an eclipse of the sun or the moon. It got to such a point, in fact, that eventually a Saros cycle was developed. The word Saros is derived from the Greek repetition. We discovered that the circumstances of eclipses recur, take place again after a certain number of years. This is kind of like, if you will, when you go to Las Vegas and you play the one-armed bandit, you pull down the slot and you hit the 3 cherries or the 3 tomatoes or whatever. There are 3 separate cycles. There's the cycle of first the moon either arriving at new phase or full phase, and you have to have the moon either at new or full for an eclipse to occur. You also have to know where the moon is in its orbit relative to the Earth, the distance of the moon relative to the Earth, whether it's near or far. But most important of all, you also have to know when the moon was going to cross that plane of the Earth's orbit. Again, tilted at 5 degrees, but you had to know when it was going to cross either to the north or to the south. And if it crossed at the time of a full or new moon, there you had an eclipse. And believe it or not, they were able to figure this out. The Babylonians and the Chaldeans of thousands of years ago discovered that every 18 years and 10 and a third or 11 and a third days, it all depends upon how many leap years intervene in that 18-year period, whether or not it's going to be 10 or 11 days. But they were able to figure this all out. I think about this a lot. I say to myself, if I were to go out today and stop 10 people on the street and ask them a question, the question being, can you tell me how the moon cycles and phases? How does it go from a crescent to a half phase to 3/4 to a full phase and then back over to 3/4 and half and then a crescent again? How does the moon do that? And you know what? I would bet 9 out of 10 people probably would look at me like deer in headlights. They probably wouldn't be able to tell me one way or another how it's done. This is the 21st century, right? We should be knowledgeable enough to be able to say and know such things. This is the space age. And a lot of people don't know that. But the people in the so-called Stone Ages of hundreds and thousands of years ago were able to figure out how this cycle of eclipses take place. I'm going to show you how this Saros cycle works. Here you see a map for the eclipse of the sun, the total eclipse of the sun on July 20th, 1963. There are many Saros cycles going on at the moment. This was Saros number 145. They come in families, if you will. Okay, this area that you see here is the region where the sun is going to appear partially eclipsed by the moon. These lines that you see tell you how much of the sun is going to be covered. If you were underneath this line, like for example, Los Angeles on that day, you'd see 25% of the sun covered. This line is the 50% line, so half of the sun would get covered by the moon. This line is 75%, but here's the most important of all. This is the path of totality. From this path, if you were lucky enough to live along this narrow path running about 70 miles or so, if you were lucky to live here, you would see the sun go into total eclipse for 1 minute and 40 seconds. That path of totality started over Hokkaido Island in Japan, moved over the Pacific Ocean, over Alaska, over Canada, crossed through Maine, and then ended out over the Atlantic Ocean. That was 1963, July 20th. Well, now, let's use that Saros cycle that was derived by the Babylonians and Chaldeans all those years ago. They said an eclipse would repeat, an eclipse would recur after 18 years. Okay, 18 plus 1963, that's 1981. We know that there were 5 leap years that intervened in that 18-year period, so we have 11 days. That would be July 31st. So July 31st, 1981, we should see a totality path that is practically the same, running from west to east, and the same kind of area of the of partial eclipse that would be visible as well. So let's jump ahead 18 years. Boom! Here we are, July 31st, 1981. And sure enough, look at the shape of the path of totality. And look at that zone of partial eclipse. Wait a minute. Hold on. What happened? In 1963, the eclipse occurred, and it occurred over North America. But now in 1981, it's occurring over, well, it started over the Middle East, and it goes over Russia, Siberia of all places, Pacific Ocean, and then the path of totality ended north of the Hawaiian Islands. What's going on here? Well, wait a minute. That Saros cycle, 18 years, 11 and 1/3 days, 1/3 of a day. In 1/3 of a day, the Earth has turned on its axis 120 degrees to the east. That's 8 hours. So it's not the same as it was 18 years ago. The Earth is turned. And now when the eclipse returns, it's occurring over a completely different part of the Earth. Now let's try it again. 18 more years, another Saros cycle. 18 plus 1981 is 1999. Another 11 days, that brings us to August 11th, 1999. Oh, don't forget that third of a day. The Earth again is going to turn 1/3 of the way around. So this time, same type of totality path, same region of a partial eclipse here, but now it's taking place over a completely different section of the globe. It starts now south of Nova Scotia, goes across the Atlantic Ocean, crossed through Europe. It was Europe's first total eclipse in 1999 in almost 4 decades. It was big news back then. And then the shadow path that continued down, finally coming to an end over the subcontinent of India, as I pause for a few moments to have a sip of Poland Spring. So I think now you're getting the picture. Every 18 years, just over 18 years, the shadow track comes back. The zone of visibility of an eclipse comes back. The only thing that's different is the turning of the Earth because of that extra 1/3 of a day. Let's try this one more time. So add 18 to 1999, we get 2017, but only 4 leap years intervene instead of 5. So instead of 11 days, we have 10. That's August 21st. in the year 2017. Hey, you remember that? That was 4 years ago. Remember the great American total eclipse? The eclipse that went from coast to coast across the United States. The United States was the only country in the world that would host this eclipse. No other country was touched by the totality path. And the duration of totality along that path, 2 minutes and 40 seconds. But wait a minute. Hold on for just 1 second again. You remember back when this whole thing started in 1963? In 63, the shadow also passed over North America. There you go. There you see it right there. And now all of a sudden, after, well, let's see, 54 years, the shadow again tracks across the same part of the world, North America. So that's another cycle. Notice also that the eclipse actually gets stronger. I almost feel like I should be playing the theme song from Rocky, Getting Stronger, because with time over the span of Saros cycles, in this particular case, the shadow is getting wider and the duration of totality with each passing Saros cycle is getting progressively longer. So from 1 minute 40 seconds in 63, in 2017, it lasted 2 minutes and 40 seconds. This is yet another cycle. It's called the triple Saros. 3 Saros cycles, 54 years. It's called also the turning of the wheel, if you will. 54 years and 32 days, plus or minus 1 day. So 54 years and just about a month later, a certain eclipse will come back to the same part of the world as it was in 54 years earlier. I want you now to remember that. I don't want you to remember exiglimos. I don't know if you'll remember that. You can if you try. But triple Saros, or turning of the wheel, or here's the easiest thing of all. Just remember that number, 54, okay? Remember number 54, because that's going to play, again, a very significant role later in our talk about eclipses. And what the heck is this? This you're looking at is a Stone Age computer, believe it or not. It is known as the Antikythera mechanism, discovered in Ankara, Turkey. And Greek scientists who built this when it was new, there were 38 gears, there was a crank. We've actually looked at this, studied this. It's currently is in a museum in Athens, Greece. And this dates back, would you believe, to the year 200 BC. I tell you true, this was an ancient computer. It had gears, it had a crank, and when it was fully operational all those years ago, when you turned the crank, what this machine demonstrated was the positions of where the 5 known planets were: Mercury, Venus, Mars, Jupiter, Saturn, where the sun was, and where the moon was. And here's the thing that blows my mind is it showed where the moon was and where it was relative to the sun for eclipses of the sun. It showed sometimes the moon passing above the sun, no eclipse, or sometimes below the sun. But sometimes it would also show when the node would match the time of new moon and show when an eclipse of the sun was going to take place. What an amazing device this was. The ability of being able to predict eclipses using this amazing device, this computer, if you will, this Stone Age computer. Okay. Before the Stone Age computer came, though, men were still fighting, and still, even to this day, of course, we are still seeing people at war, nations with each other. But sometimes these eclipses can serve a good purpose. What is probably the most famous eclipse of ancient times ended a 5-year war between the Lydians and the Medes. These were 2 Middle Eastern armies locked in a fierce battle when suddenly the day was turned into night. And the sight of this total solar eclipse, which we now know occurred on May 28th, 585 BC, again, before that computer was developed, but still some learned men were able to forecast or predict that eclipse. But to the men who were fighting this war, they didn't know this was going to happen. They just saw the sun suddenly black out, startling enough to cause both nations to cease hostilities at once. And they agreed to a peace treaty and cemented the bond with a double marriage. What a pity that doesn't happen today, right? We could use a good old-fashioned eclipse to stop war, or a war, or any war in the world today, but that doesn't happen today. It did happen, though, in 585 BC. Another famous historic eclipse in which somebody was able to use an eclipse for good, or at least good for his purpose, was, well, involving this guy. You've learned about him in grammar school or elementary school, Cristoforo Colombo. You remember the old limerick? He sailed the ocean blue in 1492, but he actually took more than one trip to the New World. He took 4 voyages across the big pond, the Atlantic Ocean. And the 4th voyage was the one that almost saw him at his end, because in the year 1503, he found himself stranded on the island of Jamaica. His ship was damaged beyond repair, provisions running low. At first, he and his crew were able to get food from the Jamaican natives and trade for baubles and trinkets. And well, here you can see the natives were very intrigued by just this little tiny, metal bell. They never saw anything like that before, but by trading off these little trinkets and baubles and tchotchkes, if you will, he was able to get food and water from the natives. And Columbus figured, it wouldn't be too long before a rescue caravel would come and pick him up, he and his men. But as the days turned into weeks and the weeks turned into months, the Jamaicans finally refused to supply Columbus with any more food. And now Columbus had his own problems with his crew. They were ready to turn against him. Faced with the prospect of both starvation and mutiny, the great Italian admiral conceived of an ingenious plan. Columbus knew from his navigational tables that there was going to be a total eclipse of the moon coming up very soon. It would come shortly after the moon came above the eastern horizon, shortly after it rose on the last night of February of 1504. So he arranged a meeting with the natives just before sundown that evening, and just before the moon rose and the start of the eclipse. And he announced to the Jamaican natives that because he didn't like the way they were treating him and his crew, that his Christian God, the Almighty God, had declared to permanently remove the moon as a sign of his displeasure. Well, Columbus timed his theatrics precisely. No sooner had he proclaimed that the moon would disappear, the moon appeared above the horizon and a small bite seemed to be taken out from it. Well, the natives, as you can imagine, were terrified, running in all different directions, grabbing water and food, bringing it to Columbus, and pleading with Columbus, please, please stop. We want the moon. We don't take the moon away from us. We'll do anything you want. Please, please. What can we do? What can we do? And Columbus actually waited until the whole moon was in the shadow of the earth, the total eclipse as it was, as I mentioned. And when the moon became totally eclipsed, that's when Columbus told the natives, well, here's what I'm going to have to do. I'm going to have to go and go into my quarters on the ship, and I'm going to do my best. I can't make any promises, but I'm going to do my best to convince my Christian God to bring the moon back on your behalf. I'm going to intercede with God to try to bring, and again, I can't make any promises. And he went into his quarters and he had his little conversation with his Christian God. And if you are one who has watched The Wizard of Oz, for example, you know very well what this device is. It was, of course, an hourglass, and his God, a simple hourglass, he was using that to time out totality. Finally, a few minutes before the end of the total phase of the eclipse, he stepped back outside and announced to the Jamaicans that his God had pardoned them. He will forgive them so long as so long as the Jamaicans provide Columbus and his men with water and food. He will bring back the moon. And guess what? There it was. The moon, sure enough, was returned to the Jamaican natives. Columbus and his men had no more problems. They gratefully, the Jamaicans did, supplied him with all the food they needed and supplies until they were finally rescued and they were returned to Europe. Okay, so the science of eclipses, what does it all boil down to? You know what it all boils down to? Shadows. That's it. That's all it is. Shadows. The Earth casts a shadow into space. The moon casts a shadow into space. The sun, of course, is the source of light that causes the shadow. And as long as we know where the shadow is going to be at any one moment, that is the secret of prediction of eclipses. Now, I'm going to show you a very interesting thing that happened a few years ago during a playoff baseball game. This was between the Washington Nationals and the San Francisco Giants. They were playing a playoff game. This was at Pac Bell Park in San Francisco. I want you to listen also to the play-by-play announcers as this this mysterious thing happened during the time when the game was being played.
Be a big pitch for Madison. And with a strange shadow being cast mid-pitch as a result of a blimp or a plane flying overhead. It's 2 balls and a strike to LaRoche. Even Adam had to look up and say, what is going on here? That would be the blimp. The lights went out. No clouds. Beautiful sunny day. It's hard enough to hit Madison Bumgarner.
Well, yeah, all right. It is hard enough to hit Madison Bumgarner, but you saw what happened. The shadow of this blimp created the giant shadow on the playing field. And to echo what the play-by-play announcer said, the lights went out. Okay, well, this is a microcosm of actual eclipses of the sun. Well, I'm going to show you a different type of giant shadow, not of a blimp. This shadow that you're seeing now is the shadow cast by the moon on the surface of the Earth. Yeah, no baseball playing field. What you're seeing here is the Earth. This is Europe. And this picture was taken from the now defunct Mir space station in 1999. Remember, I mentioned in 1999, it was the first European eclipse of the sun in almost 40 years. And there you see what happens. The moon casts this black blotch of a shadow onto Europe. And if you were anywhere inside of this blotch, you had a chance to see the sun become totally eclipsed. You think the lights went out when the blimp passed by? The lights really went out during this total eclipse of the sun. We're going to talk about total eclipses of the sun in just a moment. But first, let's get the moon out of the way. As I said, everything in space, and you and I too, cast a shadow by sunlight. The Earth casts a shadow out in space, a long conical shadow that runs, almost 1 million miles in length. The moon is only 250,000 miles away from the Earth. And so there's plenty of room for that moon to move into the shadow and become completely immersed in the shadow of the Earth. Now, the thing is, the moon doesn't shine on its own. You know that. It shines by virtue of reflected sunlight. So logic dictates that when the moon goes into the shadow of the Earth, all the sunlight is blocked from it, and the moon should black out, right? No, it doesn't. And you could actually see, this is a view, a composite picture of a total eclipse of the moon. The moon moves into the shadow of the Earth. You can almost see the circular shape of the shadow. Anybody out there who believes that the Earth is flat, well, keep this in mind. If the Earth were flat, no way could it cast a circular shadow. Only a circular object or a spherical object could cast that circle. And indeed, you see that here. But what about this color? The moon doesn't black out. During total eclipse, the moon actually turns kind of a reddish color or a coppery color. Some people today call it a blood moon. So why does it turn blood red? Well, it does so because of our atmosphere. Now, we live on an Earth. The atmosphere, of course, allows us to live here. We take in air every single day of every single moment of our lives. And also, we have different colors of the sky. When the sun is high in the sky, and you remember from Earth science class that your teacher would take out a glass triangle, a triangular piece of glass, and break sunlight into different colors. Sunlight is not bright white. It is actually composed of the colors of the rainbow. The short wavelength of light tilt toward blue, and that's why when the sun is high in the sky, it takes a shorter distance to reach your eye, and we get a blue coloration up there. The official term for it is Rayleigh scattering, if you remember again back to your general science days. But when the sun gets low in the sky, down near the horizon, instead of blue, the color that takes a longer period of time for that sunlight to reach your eyes. It's going through a longer wavelength, if you will. And as a result, the color now is tilting more toward yellows and oranges and red. So right along the horizon, right along the edge of the Earth, we have a ruddy or red coloration. Now, when we have an eclipse of the moon here on the Earth, if you were an astronaut on the moon and looking up at the sky, what you would see the Earth coming in front of the sun. From the moon, our eclipse of the moon is an eclipse of the sun because the moon the Earth is blocking the sun and its light from reaching us. But because of the atmosphere, and the atmosphere acts like a lens, if you will, right along the edge. Remember that ruddy or orange coloration? It's like a red ring in the sky. And so the sunlight, instead of being completely blocked, gets bent through the edge of the Earth, and that makes a red ring around the Earth. And that red light falls upon the moon, and the moon during total eclipse, instead of disappearing, lights up a ruddy or coppery color in the sky. And as to who can see it, an eclipse of the moon, be it a partial or a total eclipse, and believe it or not, total eclipses of the moon are much less frequent than total eclipses of the sun. But you say to yourself, well, how is that possible? You may very well have seen a total eclipse of the moon, not just once, maybe several times in your life, but you may never have seen a total eclipse. But the reason is, remember, a total eclipse of the sun is visible only from a very, very narrow path. And you have to be very lucky to be in that path to see totality. But for a total eclipse of the moon, the place that will see it will be the dark side of the Earth, the night side of the Earth. So everywhere where you are in the night part of the Earth, and everywhere where the moon is above the horizon when the eclipse is taking place, we'll see a total eclipse. So in this case, for example, North America and South America on the night side during a total eclipse, all of these people in both continents get a chance to see it. And I'm not talking about thousands or millions. I'm talking about billions of people being able to see, weather conditions permitting, a total eclipse of the moon. And it's just like being in a movie theater. Think about this. Next time you're in a movie theater, you go in, you sit down. This is before the movie. You sit down and other people sit down with you. Make believe that you and all the other people in the theater are people who live on the same side of the Earth. Now the technician turns down the lights, and on the screen, you're looking at a blank screen, right? No big deal. All of a sudden, on that blank screen is a movie, and you're going to be entertained for the next 2 or 3 hours. Well, the same thing with a lunar eclipse. Everybody on the dark side of the Earth, that's like being in the movie theater. You're looking up at the moon, it's like looking at the movie screen. And when we have an eclipse, it's kind of like a game of shadow play on the moon's disk. And the moon also turns different colors. It can go from bright yellow before the eclipse to, again, that ruddy color during totality. That too lasts in total maybe 2 or 3 hours, just like the movie. So you see, it's just like being inside of a movie theater when you're watching a total eclipse of the moon. Now, we just had a total eclipse yesterday morning. I tell you true, there was a total eclipse of the moon that took place yesterday morning. Did you see it? No, you didn't. You know why? Because that eclipse began at the moment that the moon was disappearing beyond the western horizon for us, and the sun was coming up in the east, and it was becoming daylight. In other words, we were not on the dark side of the Earth when that total eclipse took place. So we did not see it. Now, if you know a friend or relative who lived, let's say, in California or Arizona or Colorado, or as far as, let's say, Missouri, any place west of the Mississippi, they probably saw the eclipse. Why? Because further to the west, it was still dark. The moon was still above the horizon. So they were able to catch at least part, if not all, of yesterday morning's total eclipse. And we missed out. We missed out on that. But don't fret. We've got another eclipse of the moon coming later this year. And it's a very easy day to remember. It will be the Friday before Thanksgiving. Friday, November 19th, the moon will again be eclipsed by the shadow of the Earth. And it's going to happen early. Set your alarm clocks, 4:19 in the morning. And I must tell you also, it's not going to be a total eclipse, but it's going to be almost a total eclipse. More than 97% of the moon is going to be inside of the Earth's shadow on that occasion. And while it's not going to be total, it'll still be deep enough in the shadow to bring out probably that red or coppery color, and it'll look probably very much like what you're seeing on the screen now. And you see the bottom part of the moon still bright. That's the edge of the moon that's just outside of the shadow of the Earth. So make a note, Friday, November 19th, 4:19 in the morning, get up early, step outside. You'll see the moon looking rather different from its normal bright guise. Take a look now. Have you ever noticed that the moon and the sun in our sky appear to be pretty much the same size? Now, how can that be? We know, for example, that the sun is much bigger than the moon, much, much bigger. In fact, 400 times bigger in diameter than the moon. Yet the moon appears the same size as the sun, because although the sun is 400 times larger than the moon is 400 times closer to us than the sun. The moon is 250,000 miles. The sun is 93 million miles. So you divide 250,000 into 93 million, you'll get about 400. And that's why both appear to be the same size. Well, it's not always that way. You see, the moon goes around the Earth not in a perfect circle, but it goes around in an ellipse. And in an ellipse or elliptical orbit, sometimes it could be relatively close and sometimes it could be rather far away. When the moon is closest to the Earth, we call that perigee, 221,000 miles away. And when the moon 2 weeks later moves to the other side of its orbit, it then reaches the apogee point, the point furthest from the Earth, 253,000 miles away. There's a variation of approximately 12% between near and far. And that means also that in the sky, the moon varies in size. It's quietly pulsating, if you will, depending upon how far away it is from the Earth. When it's far away from the Earth, we have a smaller moon. And when it's near to the Earth, and when it's at its near point and also at full phase, the news media of late in the recent years refer to this as the supermoon. And you know what? Along with having a total eclipse of the moon yesterday morning, the moon was also at perigee. It was closest to the Earth. And so yesterday was not just a total eclipse of the moon, it was a total eclipse of the supermoon in our sky, as if that made much of a difference in, the views of the eclipse. However, I said that 2 weeks later, when the moon is on the opposite side of its orbit, it's at the far end and it's also smaller in size, comparatively speaking. That's going to play a very important role in what's coming our way 2 weeks from today. Look at this diagram. Here we see the sun is off to the left, off out of the view of our monitor here. This is the moon. Here is the shadow, the conical shadow, the dark conical shadow that is cast down toward the surface of the Earth. But look what happens. Again, the moon is going to be near the far point of its orbit, about 250,000 miles away. And it's going to be so far away that it's just not going to get to the Earth's surface. The tip of the shadow does not make it to the surface of the Earth. It misses by, anywhere from a few hundred to sometimes a few thousand miles. But here you go. Here's the red spot there. What would you see if you were there on that red spot? Directly underneath that dark conical shadow, but again, not reaching the Earth. You'd see this. This is what you would see. You would see the silhouette of the moon, but you would also see shining around the moon a ring of sunlight. Because when the moon is near its far point in its orbit, as it will be in 2 weeks, and coming in front of the sun, it's going to be a little bit too small to cover the sun completely. So you see, there are times when the moon is large enough to cover the sun completely, but there are other times when it's not. 2 weeks from now, it's going to be one of those it's not situations. And it's just like, you want an analogy here, reach into your pocket, get out your wallet or your purse, and get a nickel and get a penny. Make believe the nickel is the sun, make believe the penny is the moon. Now, I challenge you, take that penny and cover that nickel up completely. Can't do it. Why? Penny is smaller than the nickel. Why in 2 weeks won't we be able to cover the sun completely? Because the moon in the sky will be smaller than the sun. And so, people on that morning, Thursday morning at sunrise, in the right spot, will see a pretty amazing sight, actually. Not as good as a total eclipse, but what they will see will be the sun morphing into what has been popularly called a ring of fire. And that's especially beautiful when you consider when this is happening at sunrise with the sky red and the sun appearing as a yellow or yellowish orange disk. This view of the ring or ring of fire is going to run along this path. It's going to be unusually wide, I might add. It's going to be about 300 miles wide. And you see these ovals consider those the footprint of the shadow as it moves across the surface of the Earth. It starts just north of Lake Superior in Canada, runs through Canada, James and Hudson Bay, moves through the Ongava Peninsula. In fact, there's a place up here where Inuit Eskimos, a population of about 1,500, a little town called Pangnertung, they played they played host to a total eclipse of the sun in 1979, and now they're going to play host to a ring eclipse of the sun in 2 weeks. And look at that! Look at the path. It goes right over the North Pole, for goodness sake. I do hope Santa, Mrs. Claus, and the elves are aware of that. We'll give them a chance to, what goes on at the North Pole on a regular basis? 6 months it's bright, 6 months it's dark. But at least here's something interesting, that right around the time of the summer solstice, they're going to have a ring eclipse of the sun. Then the shadow, or anti-shadow, because it's not a full shadow, rolls off the top of the Earth and comes to an end somewhere in northeastern Siberia. So the key is you have to be in this path. And again, it starts in Canada, runs pretty much through much of Canada. Well, many people I know, good friends of mine who are eclipse chasers, they actually go and chase these things. They were making extensive plans. Oh, I'm going to be in Canada for that eclipse. I'm planning to see the Ring of Fire and everything. No, you're not. You're not. You know why? Things are opening up, thank goodness. They are opening up slowly but surely. The pandemic slowly but surely is releasing its hold on us, and restaurants are opening, and soon Broadway plays will be opening, and soon the schools will be opening to full capacity. But unfortunately, the borderline between our country and our neighbor to the north, Canada, is not opening, not in the immediate future, certainly not in 2 weeks in time for the eclipse. And so many people who wanted to see this spectacular sight of a ring in the sky are going to be disappointed. They're not allowed into Canada for the eclipse. So what are you going to do? Well, first of all, let me show you an animation of the shadow, the way it moves over the Earth. That red zone that you see, that's where the ring is going to be visible from Lake Superior, across Hudson Bay, across the North Pole, and then disappearing over Siberia. But notice there's a much larger shadow, the penumbra. That's where you can see the moon partially cover the sun. Okay, well, here's a map. They have 3 lines here. Here's the line here that delineates the zone of where the eclipse is going to be visible. Anybody who's located south and west or below to the left of this line will not see anything. So if you live in Florida, if you live in Georgia, if you live in at least part of Georgia, southern and central Georgia, Texas, Louisiana, out west to California, you're not going to see anything of this eclipse because the eclipse is going to end before the sun comes up over the horizon. But you want to know what? I think that's democratic, because all the people who are below this line saw yesterday morning's total eclipse of the moon. So they saw the total eclipse. We were not able to see that. But now the worm has turned, so to speak. Now it's our turn to see an eclipse, this one of the sun. So everybody who is above and to the right of the line will see the eclipse. We'll be able to see at least a partial eclipse of the sun. Now, this line up here, anybody who lives above this line will see the eclipse start right after the sun comes up. As soon as the sun comes over the horizon, the eclipse will begin. You'll be able to see it from start to finish. But the most interesting place to be will be along this middle line right here. This middle line delineates sunrise, and it also delineates the time or the occurrence of maximum eclipse. In other words, cities and towns that live near or along this line will see the eclipse, but they will see the eclipse at sunrise. At that point in time, the eclipse will be peaking. So the first half of the eclipse will not be visible because the sun will be below the horizon. We'll miss out on that. But when the sun finally comes up above the horizon, we're going to be right smack in the middle of the eclipse and right smack at the point of the maximum of the eclipse. So the folks who live in Sault Ste. Marie, in Michigan, in Toronto, Ontario, in Philadelphia, Atlantic City, Asbury Park, New York, Montauk, these places near to that line are going to be in line to see the sun at its peak for the eclipse when the sun is coming above the horizon. All of your lives, most of you, I'm sure, have seen the sun. Maybe you've said to a friend, hey, let's go watch the sunrise. Tomorrow morning, let's go down to the beach and watch the sun come up. and you go down to the beach and the sun comes up, and this is pretty much what you see when the sun comes above the horizon. Again, most mornings of your life, that's what you see when the sun has come up. But come 2 weeks from today, actually 2 weeks from this morning, the sun is going to come up not looking like that. The sun is going to come up looking like this. Nope, not like a big red circle. 4/5 of the sun's diameter is going to be behind the moon. So it's going to come up looking, as we mentioned at the start of the program, like a fiery scimitar or sickle, or if you will, maybe a slice of cantaloupe melon, or if you will, a horseshoe with pointed tips. The time when the sun will come up within a minute or two on Thursday morning, June the 10th, 2 weeks from now, will be 5:24 a.m. 8 minutes later, after the sun has come up, the peak of the eclipse, maximum 5:32 in the morning, and then watch quick because the eclipse will be completely over by 6:30. So make sure that your alarm clock is set early enough, and make sure also that you have a clear, flat, unobstructed view of the sky to the east-northeast, so you don't have any buildings or trees involved and blocking the view of your rising sun. This has happened. We have had a sun eclipsed to this magnitude at sunrise here from New York only twice before in the last 150 years. In 1875 and again in 1959. We have not had an eclipse of this magnitude or this type of eclipse happen since 1959. So let's hope for clear weather, and we'll have a chance to see it and look for it. Now, the interesting thing also, as our bird flies away, is when the sun starts appearing above the horizon, the cusps, the two ends of the crescent, are going to become visible first, and they'll be pointing straight up. And since the peak of the eclipse comes shortly after sunrise, the cusps, the crescent, is going to swing around to the left relatively rapidly. Let me show you here. Watch carefully now. Here comes the sun. The cusps are straight up at first, and then swing around. There's maximum eclipse. And then as we move past the maximum, the moon moves off the sun's face, moves away to the left, and again, it's all over by 6:30. Make sure you don't hit your snooze alarm that morning. You hit it, and then you wake up like at 6:15. Whoa, wait a minute! By that time, the eclipse is practically over. So you don't want that to happen. Now the liability part of our talk comes into play. Don't look at the sun directly with a telescope or binoculars, or don't stare at the sun. The problem is that you have to contend not only with visible light, and let me assure you that the visible light is very, very bright, 400,000 times brighter than the light of a full moon. So not only are you going to compete with that, but you're also going to compete with the ultraviolet rays of the sun, which are the burning rays, which give you a suntan. You don't want that to land on the retina of your eye, and you don't want to have the infrared rays land on your eyes either. And you know what? The funny thing is, people think that it is the eclipse. We tell people always when there's an eclipse, don't look at the sun. And what they think is that it's because of the eclipse that we can't look at the sun. I remember there was a phone call. In fact, it was 4 years ago with the big eclipse we had in 2017. A phone call came into the Hayden Planetarium. Let me tell you what it sounded like. The phone rang, and the astronomer who was at the desk picks up the phone. Good afternoon, Hayden Planetarium. Yeah, hi. How you doing? Yes, sir. What would you like? About that eclipse that's going to happen tomorrow. Could you tell me something? Yes, sir. What would you like to know? When is the eclipse going to come to an end? Tell me what the end of the eclipse is. Okay, according to our calculations, here in New York, it'll end at 2:54 p.m. tomorrow afternoon. 2:54. Let me write that down. 2:54. Okay. Yes. Is there anything else you'd like to know? Yes. So it ends at 2:54. So can I look at the sun after that? No. You don't look at the sun after the eclipse is over. The sun is dangerous all the time for the reasons I just mentioned. Visible, infrared, ultraviolet radiation. So what do? You say to yourself, well, Joe, how am I going to watch this thing 2 weeks from now? Well, have you got a mirror? Any of you ladies in the audience watching, you have a compact in your purse? Any of you guys, you have access to a hand mirror? Get that mirror out. Now, I know that, you've seen people put boxes over their heads, poking a hole on one side of the box and letting the sun shine on the other side. Forget about that. That's old fashioned. Here's the way you're going to watch the eclipse in the safe way. Get that hand mirror and have the mirrors, the light of the sun bounce off the mirror onto a wall. Now, if you're about 3, 4, 5 feet away from the wall, what's going to happen is that the image of the mirror, the shape of the mirror, is going to be projected onto the wall. Well, you don't want that. But if you can get far away from the wall, get like 50 or 100, 150 feet away from the wall, what's going to happen is that instead of the image of the mirror, what you're going to end up projecting on the wall is the image of the sun. That's right. Try it out tomorrow or any day in the next couple of weeks. And by doing that, if you get far enough away from the wall, you'll end up projecting a circle of light on the wall. That's pretty good. There you have the image of the sun. You're not damaging your eyes. And the best thing of all is that people all around you, if you could manage to mount this mirror somehow so that you don't have to hold it like this young lady is holding it, and her hand will get tired or her arm will get tired. But you do that, everybody will be able to enjoy this view of the sun. And on the morning of the eclipse, instead of getting a nice circle, what you'll end up getting is a crescent in the sky and on the wall too. There you have it. There's your view of the eclipse, perfectly safe. Oh, you say you have a telescope and you have to see it with the telescope. Well, then don't do what that guy in the cartoon did and look through the telescope. What you do is you make a shade, a collar, if you will, and put that up near the big part of the telescope, the objective lens. You put that collar there. Then by trial and error, you aim the telescope toward the sun. Don't look through the eyepiece, but you'll be able to figure out by getting it through the telescope, project that image onto a white piece of paper or cardboard. And now not only do you have a projected image of the sun in eclipse, but now it's enlarged. If you have like a 20 or a 40 or a 60 power eyepiece, that's going to bring out not only this disk of the sun, but if there are any sunspots or solar blemishes, if you will, you'll be able to see those too, being covered and uncovered by the moon. Another great way of looking safely at the sun. Don't look again through the telescope eyepiece, but project it onto a separate cardboard sheet. And of course, the one thing that's become very popular with eclipses in recent years are eclipse glasses. Now, back in the day, we used to tell people, go to your, get a roll of film, expose it thoroughly, wrap it all up again, take it to the drugstore, have them develop it, and then what you'll end up with it is a bunch of black negatives, and you can look at the sun through the black negatives. I have a question. When was the last time you went to the drugstore to get film developed? That's passé. That doesn't work. You can look at the sun through welder's glass. That's safe. Number 14 if you are planning to do so. But how many hardware stores have welder's glass? Number 14. You may be able to find them. You probably won't. The best thing to do is if you have to look at the sun, get a hold of these eclipse glasses. The glasses are made of a special plastic called polymer, which block out the visible light, block out the ultraviolet, block out the infrared. They are perfectly safe to look at the sun with. And you can order a pair of these glasses online through Amazon. Just type in on Amazon, eclipse glasses. They sell them. They're safe. There's no problem in using these glasses. There is a company out west called, the strange name, Rainbow Symphony. I am not getting anything for mentioning this name to you, but they have been selling eclipse glasses for 30 years and no problems. So you may want to order eclipse glasses from them. If you do it now, because experience has shown me that as we get nearer to an eclipse of the sun, these glasses go really quick. A lot of people start asking for these things. And believe it or not, 4 years ago, there were actually scalpers selling these glasses. Not, a pair of eclipse glasses, they're mounted in cardboard. They'll cost you what, $1 or $2? You get maybe 4 or 5 of them for $10. I remember 4 years ago, scalpers selling these glasses the day before the eclipse. Yeah, you could have these glasses. We're selling them $30 for one glass. It's American ingenuity or whatever. But if you want to see it through these glasses, if you don't want to use the mirror method or the telescope method, I would say order your glasses now, because there's going to be a run on these. I predict in the next week, or once we get within a week of the upcoming eclipse. Of course, the best eclipse of all is a total eclipse of the sun. We talked about when the shadow of the moon was too far away for the shadow to reach the earth. But when that shadow does reach the earth and cast that dark blotch on the surface of the earth, as we saw in that satellite picture from Mir, that is a great, great spectacle. And I don't know how many of you remember, those of you of a certain age like yours truly, a Saturday afternoon, it was the 7th of March, 1970. There was a total eclipse of the sun, which passed across Mexico. It went up the eastern seaboard, the southeast coast of the United States, passed offshore. Look at this. The path of the total eclipse was, 75 miles from New York. My grandfather or my mom, they certainly, I was just a teenager, they certainly would have driven me to see the total eclipse. But the problem was, you can't drive a car into the Atlantic Ocean. And I didn't have a boat either. So I had to stay in New York and miss out on the total eclipse. And we saw a 96% partial eclipse of the sun, almost. The next day after the eclipse was over, there you see made front page headlines. The New York Times showing the total phase. Here at the bottom is a picture of a Cub Scout group in Coney Island looking at the eerie twilight that fell over the tri-state area as most of the sun was covered. Millions watch eclipse in clear sky. An eerie twilight falls briefly here, March 7th, 1970. How I would wish that we could have an eclipse like this return to our area. Wait a minute, hold on. Do you remember back at the beginning of the talk, I asked you to remember the triple Saros, the number 54, 54 years, how eclipses tend to recur or repeat, how the circumstances seem to repeat after 54 years. Well, let's see if that happens this go around. March 7th, 1970. 1970, add 54, that's 2024. And 1 month, actually a little more than a month. Remember again, the triple Saros, the turning of the wheel, 54 years and 32 days plus or minus 1 day. It's actually more like 31. And here you go, 2024, April the 8th of 2024. Remember back in 1970, the path passed to our east, out over the ocean, missing New York. This time, the path will be to the left or to the west of our area. But now I don't need a boat to get to totality. All I have to do is just drive, and I'm in the total eclipse path. The path runs from down here where the greatest eclipse will be, 4.5 minutes of total eclipse. That's pretty darn good. It'll be a little bit less as you move up into the United States. But look at this, over Texas, over Oklahoma, Arkansas, Missouri, Illinois, Indiana, Ohio, Eastern Great Lakes, Northwest Pennsylvania, and here, the Empire State. It's coming to New York on that day. Second Monday, it's a Monday, second Monday in April, 2024. There's the path of the total eclipse. Here's where you want to be, totality. And notice, if you will, we have the footprint, if you will, 120 miles in diameter will be that dark shadow that will cast a total eclipse. It's 120 miles wide, but it's moving at about 2,500 miles an hour. That's why it doesn't last very long. That's why totality will only be about 3.5 to 4 minutes as that shadow whizzes by. Take a look up here. Here's New York State. This is our eclipse. Buffalo. This blue line is the center of the total eclipse path. Buffalo will get blacked out for 3 minutes and 45 seconds. Rochester, Watertown is on the center line. Plattsburgh, on the edge of the eclipse track, just outside the path, Belmont, Penn, Syracuse. Rome is just outside the path. You could walk to totality. And Ticonderoga right on the line here. We're here. Here we are in the tri-state metropolitan area, here in the Hudson Valley. And you say to yourself, well, is it really necessary? I mean, how much? It's going to be 93% here in New York. 93% of the sun is going to be covered on that particular day. And you say, well, I'll stay here, 93%. That's pretty good. No, it is not good. Even if a small fraction of the sun is still left uncovered, you're going to miss out. The main show is in that band, that totality path that you see here. And it is an amazing sight. It is as amazing as what we're going to see 2 weeks from tomorrow morning will be. It is a total eclipse that is so phenomenal. The moon is slowly moving between us and the sun. At first, just a small bite. Then the bite gets larger and larger. The sky begins to dim. You begin to know why this moment is so terrifying to early man. And now the moment approaches when only the blinding crescent of the sun remains visible. Then the last remaining bit of sunlight shines through the craters and mountains, creating a diamond ring in the sky, followed a few seconds later by the cosmic vision of a lifetime, a total eclipse of the sun. The outer atmosphere of the sun, the incredible corona flashes out into the heavens, accompanied by tongues of hydrogen gas, ruby red flames, which we call the prominences. Now I'm going to play you right now a small snippet of audio that was recorded by a gentleman who I idolized as a young boy. In fact, he was one of my mentors in astronomy, Dr. Fred Hess, who was a lecturer at the Hayden Planetarium for many, many years. And he was also a professor of physical science at SUNY Maritime College out at Fort Schuyler. You've seen that under the Throgs Neck Bridge. Fred taught me. I once asked Fred, how do you do it? Every time Fred gave a talk, he would get like a big pop. People always, enjoyed Fred's talks. And I asked him, I said, how do you do it, Fred, that you get everybody so revved up? And he said, all you have to do is tell a story. Tell it, don't lecture. The best teachers are the storytellers who can tell a story. This particular eclipse that he saw, he brought his class, his physical science class in 1979 to Lundar, Manitoba to see a total eclipse. Fred had a deep, resonant voice, and he's out there with his class. It's 30 below zero, for goodness sake. But you know what? Nobody was feeling the cold because they were looking and gaping at a spectacle in the sky. So I want you to hear the words of Fred Hess and his students as they become enveloped by the shadow and see the grandest spectacle of nature, a total eclipse of the sun.
Hey, diamond ring! Look at that diamond ring! Beautiful. Hey, look at the prominences. Anybody with binoculars, look at the prominences. They're absolutely fantastic. Yeah. Right. Look at the red all around. Look at the red. Oh my God! Look at the red. Take a picture. Take a look. Look at those streets through that corona. Oh my God! Oh my God! Those prominences are rising up to 100,000 miles from the sun. All right, here we go. Here we go. Now it's time to put it on, no? Put your filters on again. Put the filters on. Did you see those diamond rings? Oh, yeah. How about that? Look over there. There goes the shadow. Look at it. Everybody see the shadow. Look at it. Come on! Three cheers for the eclipse.
Folks, that is just a small fraction of the excitement, the event of a lifetime. It should be on every person's bucket list. You must get into totality. You must see at least once in your life. I mean, again, should you book or travel to a place where the event in question lasts no more than 3 or 4 minutes? Yes, you should, because you're going to remember that for the rest of your life. Both astronomers and neophyte sky watchers alike speak of those precious moments in awe. And as we have seen, ultimately, the cosmic sequence reverses itself. The sun flashes back into our sights. The total eclipse is over. Most people, sadly, will never see another one again. You say to yourself, well, that's all well and good. I'm going to wait. I'll wait until it comes to the Hudson Valley for another total eclipse. Then I got good news and I got bad news for you. Here is the front page of the last total eclipse of the sun from the New York area. This was January of 1925. Look at that headline. It thrills millions. The city halt to gaze. Corona divinely beautiful. Skyscrapers blink in empty streets. This is 1925. Now the bad news. On average, any one spot on the surface of the Earth can see a total eclipse of the sun once in 375 years. But now the good news, you're not going to have to wait 4 centuries for another total eclipse to come back here to the tri-state area. No, you're not going to have to wait that long. When will the next one occur? Well, it's going to be only 58 years from now. It will happen on Tuesday, May 1st, 2079. So stick to your vitamins and do a lot of good wishing, but well, so it goes. But notice, look, the totality path starts at sunrise over the tri-state area. So 2 weeks from today, you will see a large total eclipse of the sun, an eclipse that will happen at sunrise, and you'll see 4/5 of the sun covered. But if you're around 58 years from now on that Tuesday, the 1st of May in 2079, when the sun comes up that morning, it's not going to come up like a big ball. It's not going to come up looking like a crescent. It's going to come up looking like this. An incredible sight for all who are here in the New York metropolitan area on that first day of May in 2079. I don't intend to be here. I'd love to be here, but I'm probably going to be seeing it from a different perspective. But for all of the youngsters in the audience, I hope you'll get a chance to see it. And if not, if you can't wait till 2079, please try to be in the totality path in 2024. It's right up the road on Interstate 87, a few hours drive in upstate New York or Western New York, and is well worth the trip, the most spectacular of all celestial sights that you'll ever have a chance to see. And I thank you very much. And Liz, I guess I'll throw it back to you.
Thank you so much, Joe. That was great. And I did have a question. You know, when we had the eclipse back in 2017, a lot of libraries in the area did big events, and ours, we had so many people who came out on the lawn that day, you know, adults who were helping children build viewers to see the eclipse. We had some eclipse classes, so I'm glad you gave us the information about where to purchase them. My question is, the one that's going to happen in 2024, is that similar to the 2017 one?
It's similar in the sense that you will have the partial stages, which you will need the glasses for. And when we get to totality, if you're in the zone where the eclipse is total, take off the glasses, throw away the pinhole images or whatever. You can, for those few minutes that the sun is totally covered, look at it directly with your eye. Or if you have binoculars or a telescope, you can actually look at the sun for those few moments of totality without harming your eyesight. As you heard Dr. Hess on the audio tape that he made, when totality came, he was urging his students, look at the prominences, look at that corona, urging them to look at the. But the one thing that bothered me when we had the eclipse 4 years ago, here is this great spectacle, and here's totality, and what are people doing? They immediately raise their phone up and they're starting to look through the image that appeared on the phone. No, don't do that. I mean, I know you want to get a recording of it, but you know, put it on a tripod or something. You want to look at it. You want to look all around as the horizons change color and as the shadow of the moon moves overhead. You want to do that. You want to drink it all in. It's more than an experience. Every fiber of you gets involved during those few magic moments of totality. Now, 4 years ago in 2017, here in New York, we had about 75 or 77% of the sun covered. Ironically, the one that's coming up in 2 weeks is going to be about 80%. It's going to be a few percent more than what we had 4 years ago. The one in 2024, if you stay down here, you'll sit 92, 93%. But again, that's not enough. You got to knock out the entire sun, even the tiniest of sliver, to see the grand spectacle of totality, to see the sky darken, to see the stars come out in the middle of the day, for goodness sake. That diamond ring effect as the last little bit of sunlight disappears. In the last 30 seconds of total eclipse, the last 30 seconds before totality is like being in a Broadway play. If you've been to Broadway and you know just before the show begins, the technician turns the rheostat or dimmer switch and lowers the house lights, and the lights start dimming and coming on down. Literally, that's what it's like in the final 30 seconds of totality. From daylight, all of a sudden, it starts getting dark. And you can understand when you experience that for yourself, you can understand why the ancient people, when this was happening, they thought that they were losing the sun forever, and they thought that the world was coming to an end. It just absolutely blows. I'm not a religious person to any degree. I do go to church, but if you want to get religion real fast, you go to see a total eclipse of the sun, because that just will absolutely knock your eyes out. It is just amazing.
Hey, Joe, I have to tell you, it's like you're talking to us from space because you have your camera covered. So the screen is just black right now.
Oh, I'm sorry. I'm sorry.
It was very effective. It was very
Sorry
effective.
about that. It's like a voice.
I don't know if
It's
anyone
like a
has
voice
any,
from. It's like a voice from beyond.
It was. I don't know if anyone has any questions. We just had a lot of compliments in the chat, but I didn't see any questions. So if anyone has any questions, feel free to unmute yourselves and ask now.
We be sure that the glasses you purchase really are safe.
The company I mentioned, Rainbow Symphony, has been in business for 30 some odd years, and yes, they are safe. The best way that you know that they are safe is that on the Eclipse, and they're cardboard. They're made out of cardboard, these Eclipse glasses. If they have the specifications on the side of the glass, there's a special code number or whatever that tells you that the glasses have been inspected and that they are safe. There were some faux glasses that were being sold by people that had little pinholes in it, or that they had a scratch or two. No good, no good. You have to get the Eclipse glasses from a reputable manufacturer. And like I said, with Rainbow Symphony, and again, I'm not getting anything from them, but I know the guy who runs it, and he has quality equipment and quality lenses, and I think you can get you could be sure that if you do purchase a glass or Eclipse glasses from them, you'll have no problem being able to watch the eclipse. You know, the sad thing about this eclipse, it's going to be really tough. If we have one of those mornings where it's very hazy and the sun comes up above the horizon looking like a maraschino cherry, or in this case, a maraschino crescent or whatever, you know, how many of you in your life have seen the sun low in the sky and have, you know, maybe seen a sunset or sunrise, like, oh, look at that. And you've stared at it for a good number of seconds, or maybe even a minute or two. The problem is, yeah, the visible light is being attenuated. The ultraviolet, the burning rays are being attenuated, but the infrared rays are still getting through the haze. So maybe it wouldn't take, you know, 30 seconds to burn or cause problems with your eyesight if you stared at the sun when it's high in the sky. Maybe it would take more like, you know, 4 or 5 minutes, but still, you're not supposed to do that even when the sun is low in the sky. So if it's low and it looks like that, take a look, you know, take a short little glimpse of it, but don't stare constantly at it, because again, the ultraviolet, the infrared is still getting through the haze and maybe doing some damage to your eyes if you're looking at it without any filtration or any kind of special instrument.
Have some bad news. Someone was looking it up already on Amazon, and the earliest delivery date is June 10th.
Aha.
I know.
You see, I told you. Well, you could try Rainbow Symphony. Maybe if you beg the guy who runs it, please, can you get it to me before June the 10th? Yeah. It always happens that there's always a spike of interest. The closer you get to an eclipse of the sun, the more and more people hear about it. And I tell you, 2 or 3 days before the eclipse, I'm sure the radio and TV people are going to start announcing it. And that's when everybody's going to start, you know, running and looking for ways to look at it. And why do I think that all of the beaches and all of the seashores along the New Jersey and Long Island and Long Island Sound coastline, why do I think there are going to be a lot of people that morning of June 10th out at the beach to watch the sunrise? Or in New York City, a lot of people will probably be on the roofs of their buildings trying to see if they can see the sun come up. Did you hear the Empire State Building is opening their observation deck, the 86th floor observation deck, early? Normally you could pay to get on the observation deck, $40. On that morning, for the privilege of being up on the 86th floor before they usually open at 5 a.m., they'll charge you $120. So they're charging 3 times more than they normally would for you to see the eclipse from the top of the Empire State Building on the morning of the eclipse.
Do they give you glasses?
Yes, they do.
Oh, wow, okay.
And they also promised, I think, Starbucks coffee.
Hmm.
So you get something for your 120 some odd
Yeah.
dollars.